All right, let's continue our triangle, perimeter, and area problems with number 3. Write a formula for the area of a right triangle in terms of its base B and its hypotenuse C. Okay, so certainly there's just not enough room here. Oh, low battery, 10%. I can make it. Okay, there's not enough room on the screen right here or on this little box in order to do that problem, so we'll have to start writing elsewhere. But before I do, I'm going to model this process yet again, and that is, what is it that we're looking for? What type of formula are we trying to write? And it is the area of a triangle. It doesn't matter if your triangle is a right triangle or not, you still compute the area exactly the same way. And that area formula is 1/2 base times height, right? That's the same formula we have right there, 1/2 base times height. In terms of its base and base B and its hypotenuse C. So we're seeing this terminology again, in terms of. That means that over on the right-hand side, it basically is the information, the variables, the side links that you need to know in order to compute the area. Right now, this area formula is in terms of base and height, right? Because we need the base and we need the height in order to calculate its area. But problem number 3 is asking us to rewrite it in terms of base and hypotenuse. So the base is already done. Check, check. But the hypotenuse is the C value. It's not the H value. So this is the one that we need to deal with. That's right there. I need to get rid of that H in some kind of way and rewrite it with a C in its place. So look at this right triangle. Is there something that's missing from that right triangle? Let me get rid of this circle around there. I have a B for the base. I have C for the hypotenuse. There's something missing. It is the right-hand side over here. We usually put an A there, right? So it's an A and a B and a C. So A squared plus B squared is equal to C squared. But for this problem, since this segment down here is the base, that means that this perpendicular segment over here is the height. There we go. Look, it says, ah. Maybe there's an aha moment there, or possibly not. Okay, anyway, so I'm going to get rid of the A because we're going to use it in terms of this B, this H, and this C. And I'm going to write the Pythagorean Theorem for that right triangle and use that with some substitution. So I am going to skip down here a little bit and get a little bit more room because I'm going to need it. Definitely going to. Look at that lovely straight line that I've got going on. Okay, so I'm going to redraw my right triangle with my pieces labeled. We said that this is our base, this is our height, and of course this is our hypotenuse for that side. Okay, and I'm working with 1/2 base times height, but I want to get rid of H. Okay, in order to do so, I need another equation that relates the H and the C together, and that's going to be the Pythagorean Theorem. And for this particular example, the Pythagorean Theorem is going to be a B squared plus an H squared, doesn't matter which one of those comes first, is equal to C squared. Okay, so now what I need to do then is, notice that this second formula we just wrote down also has an H in it. And remember, H is what we need to get rid of. It's the thing that's messing us up in the original formula. We need to replace it with a C. So what I'm going to try to do after this bell finishes ringing is solve this Pythagorean theorem equation, or this Pythagorean formula for H. How do I get H by itself there? I've got a B squared over here that's right beside it, and it's being added to. It's being added to the H squared, so to get rid of it, I'm going to subtract B squared from both sides. I'm going to subtract B squared, and that will cancel it out over here, and I'll be left with my H squared is equal to, now these are different. They're not like terms, so I just list them. C squared minus B squared. All right? And I'm solving it for h. It's being squared, so undoing a square is taking the square root. Again, it's just like using the Pythagorean theorem ordinarily with numbers. The last step is to take the square root. Now, as I've mentioned in every single video so far, when you take the square root, when you're solving a quadratic equation, which is what we have here, you're supposed to have two answers, a positive and a negative. But does it make sense for this height to be negative after we take a square root? Nah, it's a height. It should be a positive number. So I'm just going to have, in green, my height is equal to, and now on the left-hand side, there is nothing to simplify here. You cannot break up that square root and the difference of these two squares underneath the square root symbol. There's nothing to simplify here. And I'm going to take just a moment, since I have 8%. Man, it's like I've got all day just to demonstrate that you can't do that. It's such a common mistake that what students want to do is cancel out squares and square roots to make that c minus b. But if you did that, please put a big old red X on that because it's wrong. So let me show you why it's wrong. And I'll show you in red, yes. So let's get a Pythagorean triple. A particular Pythagorean triple that most people are familiar with is a 3, a 4, and a 5. And so in this particular situation, we would have something like 3 squared plus 4 squared is equal to our 5 squared, right? Would you agree? Right? Because 3 squared is 9, 4 squared is 16. That would be 25, which is what 5 squared is equal to. So just like what I did over here, I'm going to solve this for this 4 squared over here. I'll take this 3 squared, and I'm going to subtract it over to the right side. 4 squared is equal to 5 squared minus 2, how about 3 squared? And the last step, just like we did on that step there, is to take the square root of both sides. So square root there, square root here. And the square and the square root on the 4 will cancel out, just giving me 4. And I'm telling you, like back up here on this stage right here, to leave it alone, to not do anything with this at all. I'm telling you to leave this as 5 squared minus 3 squared. Those of you who thought you can cancel these things out, look what happens. I would have 4 is equal to a total head scratcher 5 minus 3. Is that true? It is not true. That just is an example to help you understand that you cannot cancel out squares and square roots across subtraction. And the reason why, really, when it comes right down to it, is that squares and square roots are inverses, but square roots and the difference of two squares are not inverses. There's another operation up inside there, so it's more complicated than that. Okay, all of that to say that we are pretty much ready, if I can get rid of that, to take this and do some substitution, some beautiful substitution back in this equation that's right there. Here, I could have just used that arrow right there. I'm going to take that h out, this one right there, and replace it with the square root of c squared minus b squared. This is looking totally Christmas up in here. So my new equation becomes a is equal to 1/2. B gets to stay, and I'm going to take out h and replace it with this new expression, square root of c squared minus b squared. And since I don't want to box that one in red, it's going to get boxed in green and still look beautiful. There we go. I think that should sufficiently solve that particular problem. So for any right triangle, here is what you can do. If you knew its base length and you knew its hypotenuse, you can plug those numbers into this new formula here, and you could, if you wanted to, calculate the height, calculate the area that way.